In this video, we'll be discussing the concepts of mass composition based upon percentages. As you know, a percentage is generally a ratio of relationship between a part out of a whole, and in this case it represents the amount with respect to the amount being 100. In the case of the formula, the general formula for mass percentage is the mass of one of the components of a formula divided by the total mass of the formula. Or alternatively, it could be the mass of a portion of the sample divided by the total mass of the sample. We then multiply by 100 to get the fraction to become a percentage. As an example of this, we can figure out the percentage of a hypothetical element we can call C as a portion of the entire material that is comprised of two other elements such as A and B. The percentages are calculated using the percent equation. In this case, we have the various components A, B, and C. Individually, the mass of A would be 2 grams, the mass of B would be 4 grams, and an individual C would be 1 gram. If you had a formula of 1A, 1B, and 2 C's, that would represent the pie chart that you see here, and so it would turn out that the pie would be divided into a portion where half of it would be B, a quarter of it would be A, and there would be 2 slices that representing the C together, representing about a quarter of the pie graph. If you take and want to determine the overall percentage for C, we can calculate this by taking and multiplying in the numerator of the percentage equation the mass of an individual C by the number of C atoms, and in this case 2 times that would be the numerator, and then in the denominator we're going to add together all of the totals, so 2 grams of A plus 4 grams of B plus 2 times the 1 gram for each of the C's. We then can put that into our calculator. The numerator would be 2 grams, the denominator would total to 8 grams, and then finally 2 divided by 8 would be a quarter, and then multiply that by 100%, and you would end up with 25%. When we want to calculate the mass percentage for a particular compound, we are going to talk about the mass of the atoms for a particular element in a overall formula, and then divide that by the mass of all of the elements in the formula, and so that would be the part divided by the whole, and then multiply by 100. So in this example, we're going to figure out the mass percentage of one of the elements in the compound, with the compound being ammonium nitrate, and we're going to have this to a level of 3 significant figures. The formula for ammonium nitrate is comprised of the ammonium ion and the nitrate ion. The ammonium ion is +1, the nitrate ion is -1, so this comes together to give a formula of NH4NO3. In this particular case then, we need to figure out the total mass of the nitrogen atoms in the formula and divide by the total mass of all the atoms in the formula. So, in this particular case, the total molar mass, the sum of all of the atoms in the formula, getting the average atomic masses from the periodic table. Adding those all together gives 80.05 grams per mole. In this example, we're going to calculate the percentage of the element for the formula of ammonium nitrate. In this case, we are going to take the mass of each of the elements and divide by the total mass, and then multiply by 100. In the case of nitrogen, there are 2 nitrogen atoms, so we would first look at the periodic table and see that the nitrogen is approximately 14. 2 times 14 is 28, a little bit more than that. Divide that by the total and multiply by 100, and your calculator is going to give quite a few digits here. We got to recognize that we only want 3 sig figs, so in this case we're going to have 35.0. In the case of hydrogen, there are 4 hydrogens in this formula. So 4 times the atomic mass of hydrogen, which is about 1, turns out to be 4.032. Divide that by the total, multiply by 100, and in this case we are going to deal with the 3 sig figs, and note that the first insignificant digit is greater than 5, so therefore we need to round up, so the percentage of hydrogen is 5.04. And then in the case of oxygen, there are 3 oxygens. Oxygen right around 16, and so in this case 4 times 16 is 48, and then divide that by the 80.05. This is going to be a little bit more than 50%, and in this case the first insignificant digit causes us to round up. So our percentage in this case turns out to be 60.0. At this point, you should check to make sure that those total up to 100%, 35 and 5 is 40, plus 60 is indeed 100%. As an example of how to use the percentage to figure out the mass of a particular element in a compound, if we have the question, how many grams of nitrogen are there in 48.5 grams of ammonium nitrate, we're going to initially start out using the percentage that we calculated previously for nitrogen, which was 35%. We would then plug that into the percentage equation with the total mass of the compound being in the denominator of the fraction, so 48.5, and then rearrange this equation so that you end up with the 48.5 times 35 divided by 100, and then that would give a, in your calculator, 16.97, with the first insignificant digit being greater than 5, causing it to be rounded up to 17.0.